The Sunshine Skyway Bridge accident in 1980 was one of the major motivators for the development of Tampa Bay ports. In May of 1980, an inbound freighter was overtaken by an intense early summer, late spring squall line and had 60-knot winds on the beam, blinding rain that forced the vessel out of the ship channel just as it was approaching the center span of the bridge. It collided with one of the main bridge supports, and the southbound span of the bridge collapsed, killing 35 people and shutting down the main port facilities or the main shipping channel for about 6 weeks or so. And Tampa Bay accounts for over half of all the refined petroleum product for the state of Florida, and people were literally, gas stations were running out of gasoline, oil-fired power plants were running out of fuel oil, and Disney World came close to going dark, I'm told. So part of that led to the development of ports. So now the harbor pilots know exactly what the waves, winds, currents, tides are as they start their transit. It's about a 4-hour transit from the entrance to the main ship channel up to some of the main port facilities in downtown Tampa. So now the pilots know what conditions to expect all along that transit so that they can plan accordingly, hold the ship offshore if conditions aren't favorable, or take advantage again of favorable wind and tide and current conditions to make their transit as safe as possible. The maritime community around Tampa Bay utilizes ports constantly. Studies have shown that the number of ship groundings have decreased by 2/3 since ports came into play. There are certain zigs and zags in the ship channel that can only be navigated near slack water when the currents are very low. And now ports gives the harbor pilots that information as they're transiting into or out of port facilities. So now they can time their vessel movements very precisely related to the tidal currents. We're also starting to bring larger and larger container vessels into Tampa Bay that have very narrow underkeel clearance margins. So having the real-time water level information as well as all the other wave, current, and tide information has been a huge benefit to bringing those vessels in. We've now put a wave buoy offshore of Tampa Bay where the harbor pilots board and deboard incoming and outbound vessels, and they now know exactly what the wave climate is out there before they go out on their pilot boat or before they leave the dock on outbound vessels, so they know if they're going to be able to get on and off of the pilot boat from inbound and outbound vessels at that spot. Another major use of ports data is for dry bulk carriers. There's a lot of dry bulk material that gets shipped out of Tampa Bay for the phosphate industry, and ships agents tell me that that's one of the main drivers for getting ports here in the first place, is because they can load to the tide. If the tide is a foot or so higher than forecast or predicted from astronomical tides, they can load that much more cargo onto the vessel, which results in huge money savings or increased profit per vessel transit. The original system was installed between 1989 and 1990 and went operational in 1991. Again, at that time, it was the first of its kind. The original system was, I believe, 7 locations with about 12 sensors, tide gauges, wind, temperature, humidity sensors, and 2 acoustic Doppler current profilers measuring currents at critical turns in the ship channel. We've now expanded over the past 30 years. We now have 15 sites with over 35 sensors. We've added fog sensors, visibility sensors. We've added a wave buoy at the entrance to the bay. We've added 2 additional acoustic Doppler current profilers at critical junctions in the ship channel. And we've added an air gap sensor on the Skyway bridge that measures the instantaneous vertical clearance for vessels passing underneath the bridge, which is a concern for the larger cruise ships and some of the larger container vessels.